Hello and welcome to another Common Core Geometry video by eMathInstruction. My name is Kirk Weiler and today we'll be doing Unit number 9, Lesson number 12 on equations of tangent lines. So we've been studying tangents, tangent lines to circles throughout this unit. In the last lesson, if you weren't with us, we even learned how to construct tangent lines with simply a compass and a straight edge. Today we're going to be looking at how we can form the equations of tangent lines, which are just equations of lines, y equals mx plus b in the slope-intercept form, or we may even use the point-slope form some today, all right? But we're just looking at how can we find those equations, all right? So let's jump into that right now. Okay, little warm-up before we really get into it seriously. Let's take a look at exercise 1. Given line segment AB with endpoints at -3, -3, and 3, 6, answer the following questions. Letter A, determine the slope of AB. All right, this should be a piece of cake for you. Pause the video now and actually maybe do both A and B. A asks us for the slope of AB and B asks us to determine the slope of a line perpendicular to AB. Why don't you pause the video now and do both of those. All right, let's go through them. Simple enough, right? Find the slope of AB. We're just going to use the classic slope formula, y2 minus y1 divided by x2 minus x1. It doesn't really matter which one you think of as x1, y1, x2, y2. But I think it'll be natural to do 6 minus -3 in the numerator, and then 3 minus -3 in the denominator. That'll give us positive 9 in the numerator, positive 6 in the denominator. And if we reduce that slope to simplest form, the slope of AB is 3/2. Now remember, the slope of a line then perpendicular to AB will be the negative reciprocal of this slope. I oftentimes will kind of symbolize that by doing an M with a little perpendicularity symbol down as a subscript, and that will be -2/3. All right, so that's it. But let's take a look at letter C. Letter C asks us to write the equation of a line that passes through point B that is perpendicular to AB. What is the y-intercept of this line? So we want a line that is perpendicular to AB that passes through point B, all right, and we also want to find the y-intercept. Well, we've got two choices when we write equations of lines at this point. We can either write them in what's called slope-intercept form, and this is particularly nice if we know the slope and we know the y-intercept. And we can write them in point-slope form, and this one is particularly nice if we know the slope and we know a point that the line goes through. This is the one that we want to use this time, and we're going to be using this one a lot in this particular lesson because we know the slope of the line we want. It's -2/3, because remember, we're writing the equation of a line that's perpendicular to AB, so it must have a slope of -2/3, and we know a point that it goes through because we're told that it goes through point B. So we know our slope, it's -2/3. We know a point that it goes through, 3, 6. So we can write the equation of the line, y minus 6 equals -2/3 times x minus 3. So that is the equation of the line that we're looking for. Now, one thing that's a little bit tricky, though, is they then said, what's the y-intercept of our line? In this form, it's not possible to immediately see the y-intercept. We can if we're in slope-intercept form, but we're not here. This is point-slope form. But you can always take point-slope form and rearrange it into slope-intercept form for whatever purpose. In this case, to actually find the y-intercept. So let's do that. Let's take this thing and we're going to rearrange it by distributing the slope. That's going to be y minus 6 equals -2/3 times x. Then we have to do -2/3 times -3. Well, that's going to be +6/3, which is +2. Now watch out. The y-intercept is not +2. We still need to bring that -6 over by adding a 6 to both sides. And what we find is that our slope-intercept form, -2/3 x plus 8, tells us that our y-intercept is 8. All right? And that's an important thing to review anyway. The fact that you can always take a point-slope form of a line and rearrange it into a slope-intercept form, again, in case you need the y-intercept or some other reason. This is actually an easier form to graph in if you needed to. All right, let me step out of the way, get this down, because we're going to need it when we write the equations of tangent lines. All right, let's do that. Let's get into some tangent lines now. Here we go. Nice, easy problem. Exercise number 2. Circle A is shown below with a center at the origin and a radius of 5. Point B lies on the circle and has coordinates of 4, 3. The tangent to the circle at point B is drawn. All right, so letter A. Write the equation of the circle below and show that the point 4, 3 must lie on it. All right, so go ahead and pause the video now. We've talked about equations of circles. You should easily be able to write the equation of this circle, of circle A. Go ahead. All right. Well, all circles centered at the origin will have the equations of the form x squared plus y squared equals r squared. Since we know that the radius of our circle is 5, the equation of this particular circle must be x squared plus y squared equals 25. All right, that's simple enough. Now, we were also asked to show that the point 4, 3 lies on this circle. That's also easy enough to do. All we need to do is substitute the point 4, 3 into the equation of the circle and show that it's a true equation. Right? We get 16 plus 9 is equal to 25, and 25 is equal to 25. That's true, and therefore the point must lie on the circle. As it does, there it is, point B. All right, just a little review work in terms of equations of circles. Now, letter B says, what is the slope of AB? That should be a nice question mark there, since it's a question. What is the slope of AB? All right, well, go ahead and figure this out. Now, you could certainly find the slope of AB by using the slope formula. A has coordinates of 0, 0, B has coordinates of 4, 3, or you could just use rise over run, right? You could simply come in here and say, well, I had to go 4 units over, I had to go 3 units up. Either way that you do it, the slope of AB is 3/4. All right, that's the slope of AB. AB, that radius, okay? But let's take a look at letter C. Letter C asks us to write the equation of line M in point-slope form. Well, how do we do that? Well, the cool thing is, right, line M, that tangent line, must have a slope that is negative 4/3, right? It's got to have a slope that's the negative reciprocal of 3/4 because it's got to be perpendicular to radius AB, right? That's the key. Now, if we're going to go with point-slope form, we also need a point that line M definitely goes through. Now, granted, line M is graphed here, so you could read off a variety of different points it goes through. But the one point we are absolutely positively certain it goes through is point B. So use that one, right? We know it goes through the point 4, 3, so we can now say y minus 3 equals negative 4/3 times x minus 4. Y minus 3 equals negative 4/3 times x minus 4. And there's the equation of our tangent line. It was that simple. All we needed to know was the slope of our radius, which was 3/4, which immediately told us that the slope of our tangent line was negative 4/3. Then we needed a point that it passed through, but we knew that that was going to be point B, and we were able to put them all together in this point-slope form of the tangent line. Let's take a look at the final question. Letter D says it appears that line M has a y-intercept of 8, right? Right up here, y-intercept of 8. The question is that really the case, right? Prove or disprove this observation. All right, well, pause the video now and see if you can figure out whether it has a y-intercept of 8. All right, Well, the worst thing that you can do is just look at the graph and go, oh, it looks like it has a y-intercept of 8, so yes. Or, I looked at the graph, it doesn't quite look like it has a y-intercept of 8, so no. Now, the best way of figuring out whether it has a y-intercept of 8 is to take this equation, rearrange it into y equals mx plus b form, into the slope-intercept form, and see if the intercept's 8. Now, this is going to be a little messy because it's going to have fractions involved, but let's do it. Remember, right, we are in high school geometry. We have to get by our fear of fractions. We have to be able to use them. So let's do it. Let's take that -4/3 and distribute it. That will give us -4/3 x plus 16/3, right? Remember, when you multiply something like this, you multiply two fractions, multiply their tops, multiply their bottoms, 16/3, right? I'm going to add 3 to both sides. All right, so that's going to give me y equals -4/3 x plus 16/3 plus 3. Now I've got to be able to combine these two, and of course to add two fractions, they need to have a common denominator, right? I'm going to just do this work up here. That's going to be 16/3 plus 9/3, which equals 25/3. So the final equation of my line, -4/3 x plus 25/3. Here's my y-intercept, 25/3, which is not 8. 24/3, that's 8, right? 24 divided by 3, that's 8. But 25/3 is not 8. So, no. The y-intercept is not 8. It's actually 8 1/3. So it's close to 8, and there goes my pen. It's close to 8, but it's not quite 8. I felt like I had to throw the pen in the last lesson of this particular unit. I'm that angry at circles. No, I'm not. Anyway, so definitely not 8. All right, let's keep going. Let's do another problem. All right, the key to all equations of tangent line problems, and to most tangent line problems in general, the key is the fact that the tangent line will be perpendicular to the radius at the point of tangency. Right? That's the key. The tangent line will be perpendicular to the radius at the point of tangency. So let's kind of see how that plays out in a more challenging problem than the one that we just had. All right, here we go. So exercise number 3. Consider the circle whose equation is x minus 6 squared plus y plus 3 squared equals 80, and the point 2, 5. Use of the grid is optional but helpful, right? It's going to be helpful in order to visualize what's happening in this problem. So I'm going to try to use it as much as possible, but I already see a challenge, which is the fact that this circle has a radius squared of 80, and 80 is not a perfect square. The square root of 80 is not a nice number. It's close to 9, right, because the square root of 81 is 9, but it's not a hugely nice number, and we'll see kind of how to deal with that. But first, letter A asks us to show that this point A must lie on this circle. So pause the video now and show that that point must lie on this circle. All right, well, let's talk about it. In order to show that any point lies on any particular equation, we have to take that point, substitute it into the equation, and show that the equation is true. So let's do that really quickly. Let's do 2 minus 6 squared plus 5 plus 3 squared, and let's show that that's equal to 80. 2 minus 6 is -4 squared. 5 plus 3 is 8 squared equals 80. -4 squared is 16. 8 squared is 64. And 16 plus 64 is 80. So true. All right, must lie on the circle. Great. All right, letter B. Find the slope of the line segment that connects the center of the circle to point A. Well, first things first, right? What is the center of this circle? Well, the center of the circle is at 6, -3, and that's extremely important. If you look at this thing and you say, the center is at -6, +3, you're going to get this problem completely wrong. The center of this circle, right, is at 6, -3, And point A, what was point A? Point A was at 2, 5. All right? In fact, let's throw both of those points up on this graph really quick. The center of my circle is at 6, negative 3. All right? And A is at 2, 5. Now, probably even easier than me, you can actually draw a portion of this circle. I'm going to do it right now, really fast. I would encourage you to do this as well. All right? Again, hopefully it'll be kind of easier for you than it will be for me. I'm going to do something that's a little weird here, but I think you'll follow me on it. All right? So my circle looks something like this. I can't see the whole thing because I don't have enough graph paper, but this will help. What I'm trying to do right now, right, is I want the slope of this particular line. Now, we don't particularly even need this picture, obviously, to find that slope because we have the slope formula. Right? We can simply say, all right, we've got y2 minus y1 all divided by x2 minus x1. Right? We just do the slope formula. y2 minus y1 divided by x2 minus x1. You can do negative 3 minus 5 divided by 6 minus 2. It doesn't really matter. Either way, the numerator becomes 8. The denominator is negative 4. So the slope is negative 2. Right? It's just the slope of that particular radius. Okay? Now letter C asks us to now write the equation of the tangent to the circle at point A in both point-slope form and slope-intercept form. All right? Now again, we can really visualize sort of what this thing is going to look like. Hopefully. Whoa, I just fast-forwarded through a bunch of stuff. Here we go. Whew. Back to slide 4. I'd love to know how I did that. But at the end of the day, what I'm trying to do is I'm trying to come up with the equation of that tangent line. And see, even I kind of struggle getting this thing drawn, but I want the equation of this line. Right? That's what I want. Okay, the equation of that red line. Now, one thing I can tell immediately is I can figure out what its slope is. Its slope must be the negative reciprocal of negative 2. So the slope of my tangent line is going to be positive 1/2. But I also need a point that it goes through. And the beautiful thing is, well, I can't do that, but the beautiful thing is it must pass through point A. That's the point, right? I am writing the equation of the tangent line at that particular point. So now I can use that in my point-slope form. I can simply say y minus 5 is equal to 1/2 times x minus 2. And that's the equation of my tangent line in point-slope form. Now, if I want it in slope-intercept form, all I have to do is rearrange this to get it into y equals mx plus b. And that's not going to be too hard because my fraction here is 1/2. So when I distribute it, most people will feel very comfortable that 1/2 times 2 is 1, no problem there. And then adding 5 to both sides will give me y equals 1/2 x plus 4. All right? Point-slope form of the tangent line, slope-intercept form. And by the way, slope-intercept form tells me I didn't do a terrible job drawing that tangent line. It didn't quite hit a y-intercept of 4, but it was pretty close. Probably should have had it tilted a little bit more down. Anyway, let me kind of step out of the way and make sure that letters B and C are in the frame so you can copy down anything that you need. All right, let's do another one. One more problem in this unit. Let's do one that has no graph paper at all. Okay? Exercise number 4. Given the circle whose equation is x plus 4 squared plus y minus 2 squared equals 136, Write the equation of the tangent to the circle at the point 2, 12. All right, so let's do this. Now, the key here again is that the tangent line will be perpendicular to the radius that connects the center of this circle with the point of tangency. So the first thing I want to know is the center of my circle, right? What is the center of this circle? All right, well, it's -4, +2, right? Simple enough. Now, I need to find the slope of the radius that connects this and this. So I'm going to just write down my point 2, 12, and the slope, maybe of the radius, maybe I'll put a little sub r there, will be 12 minus 2 divided by 2 minus -4. 12 minus 2 is 10. 2 minus -4 is 6, and if I reduce those, I get a slope of 5/3. Now remember, that is the slope of the radius connecting the point of tangency with the center of the circle. But the actual slope of my tangent line will be the negative reciprocal of that. So the slope of my tangent line will be -3/5. Okay? Now the beautiful thing is that we have absolutely everything we need. We just have to keep in mind of sort of all of our ducks in a row. You know what I mean? We've got the slope, and we've got a point that it passes through. Remember, don't use the center as the point that the tangent line passes through. It doesn't pass through that point. It passes through this point with that slope. So I can say y minus 12 equals -3/5 times x minus 2. Since the problem doesn't tell me which form I should leave my equation in, I might as well leave it in this form, right? There's absolutely no sense in rearranging it into y equals mx plus b form when the problem doesn't ask for it and all they want is the equation of the tangent line. Often, if that's all they want, leave it in point slope form. You've got the point. You have to have the point that the tangent line goes through, and you'll figure out the slope of the tangent line by simply doing the negative reciprocal slope of the radius that connects the point and the center of the circle. That's it. Copy down anything you need to, and then we'll wrap up. All right, let's do it. Well, for no other reason, you got to see me throw a pen in today's lesson, and that's kind of fun. But getting by that, the thrust of today's lesson was all about writing the equations of lines that are tangent to circles at a particular point on the circle. The key to doing that is the fact that the tangent line will be perpendicular to the radius at the point of tangency. That allows you to then find the slope of that radius because you know the point of tangency and you know the center of the circle. You can use the slope formula there to find that slope. And then you can use the point slope form of a line to simply do the negative reciprocal of the slope of the radius, the point of tangency, put the two together in that point slope form, and you've got the equation of the tangent line. That's about it. Sounds more complicated than it really is. For now, I'd like to thank you for joining me for another Common Core geometry lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.